Been a while since I did a video on the Python Unreal object detection project. Haven't done much with it other than obviously you saw the second to last video. And what we're going to talk about today is using our own model to run the object detection. And it's going to use Tensorflow and it's going to use Keras. And I didn't actually write any of this code. I did stumble across it. And this is the equivalent model training and code that was in the original demo. The original demo uses OpenCV, and it uses the MobileNetSSD. It uses a cafe model, and this is I think the protobuf for it. This code's been around for a while. I've done videos on that code, and that's all well and good, and I think I talked about it in the other video, but and this object detector class right here is something I wrote just to wrap the clean it up a little bit with the the object detection. But this code in here comes from PyImage Search. It's Dr. Adrian. I just put it in a class. The point being is that this is using OpenCV and it's using its built-in deep neural network classes, which you can use, and I've used it before in my Halloween project, and it's great. The problem is that you can't really train it unless you want to do a cafe model, and he doesn't go into all that detail. So I found this other project that does the exact same thing, but it uses Keras and Tensorflow. So in this video, I'm just going to slowly but surely introduce everybody to Jupyter Notebooks and kind of the workflow to build a model. So what eventually we will do is we will be renaming this class to, I don't know, Cafe, or DNN Object Detector Cafe. So we know that it works, and almost all this code, it's going to be identical except for when we do the detections using the newer model. So with that said, we'll go over it real quick. We've got Unreal with the Python plugin installed. Inside of the Python plugin, we created a character based off the Python plugin, character creation. I know that sounds kind of wonky, but you can't do it unless you have the plugin installed. And again, we're just going to go over this really briefly. All this character does is it's associated with the you'll have these options in here, the module and the class, and that's what this is. And you all have seen some of this code before. We're using 0MQ to do the communication. The reason why we're doing that is we might eventually plug into different sources of information, and we want to do that real easy, and 0MQ allows you to do that. Again, this is the last video I'm just kind of going over it very quickly. We're basically getting data from the code over here. Let's see where that's at. From the server, and here's the almost identical code, but it's the sender. It has the object detector class, and it basically reads in the buffer coming, image buffer coming from Unreal, does object detection, and then it sends back the label and the object box data. This is what comes from the model, and this is what's going to come from the new model. So then all we're doing inside of the Unreal is we're just printing that out. So we're talking to the class and we're getting the object box data and we're just printing it out. Or what we're going to be doing in the future obviously is making decisions on what we need to do next once we do a object detection. I'm still kind of formulating that right now, but what we want to concentrate on now is getting into a TensorFlow environment, Keras TensorFlow environment, to where we can train our own models on the objects that we are interested in and not necessarily the objects that come with the class. Let's see, these types of objects right here. So let's get rid of that. Let's get rid of the server. So to go forward, I would suggest that you go to GitHub and you, if you can get this far, if you can get the Python set up with the Jupyter Notebook, that's kind of your homework. You need to be able to get a, this is called a Jupyter Notebook, and you need to get this up and running based off of this person's code. And you don't even have to use their code. You can get a real simple Python TensorFlow Keras set up and just do a hello world. I happen to have an older version of TensorFlow. I have an older version of Keras. So this code in here is really just a go by, and eventually I will be upgrading to the TensorFlow 2.0, and I think it's 2 point something. But the point being is that this is older code. And I think SSD is single shot detection. There's all kinds of model families, and all we're really doing is just pulling down this guy's code and getting it to work. So this particular, I split them up. One is training, and then one is just inference. So this is the actual gut. You can take all this code with minor tweaks and you can put it in a Python class, and that's exactly what I plan on doing. So in the next video on this series, we are going to replicate everything we already have, but we are going to use this model, and you can see right here that we're actually downloading. We have downloaded and we are loading his model. So this model is already trained. I know what you're saying. You're like, well, we want to train our own. Well, once you can get this far with Jupyter, Python, Keras, and TensorFlow, then we'll look at training the model ourselves, and we will probably use this original model and we will modify it. Or we might not use this model, or we might use this model in conjunction with another one that we have trained that just does very simple object detection. So I'm just, since this code is a go by, and some of it's going to have to get reworked for the new version of TensorFlow. I'm not going to go into a lot of detail, but as you can see, we are just loading a pre-trained model, and then he has this box utility class, which is very helpful. It's a lot of code. So I just pull open a pic, I load it, and then let's see, this is the preprocessor. Yeah, goes to the preprocessor, which basically makes that image to where a TensorFlow model can consume it. We do the prediction, and then based off of his box utility, which we need, those are the boxes and the labels, we get the results and we print them out. So, and then this is a bunch of code to enumerate all those boxes, and voila. So this video is going to be relatively short. It's just kind of pointing people in the direction where they need to be if they want to follow along. I realize it's a lot of setup with a lot of stuff, and I haven't necessarily made any videos that go over the installing all of this stuff, you know, to get this thing to work. So that's kind of everybody else's homework. But as you can see, this model works great. So now in the next set of videos, we will go through taking this code and putting it inside of our simple little DNN class to make our server real simple, and we will do the same thing inside of Unreal, except what'll be coming over here, this code will actually not change. The server code is what will change. Yeah, and all we'll really be doing is just changing this class right here, and the server, it won't really be any hopefully any different, not that different. We're trying to just abstract away the different model types, and then what should happen is, I'm not going to run the demo right now, is that when this guy spins around in a circle, I just put a simple cone in front to kind of show the direction of where it's looking. And in the video, I've shown that this works. And these models right here, believe it or not, these Unreal 3D objects, you know, that look like humans, they get detected by the earlier model. So now, once that's done, now we're all on the same page for anybody that's following. I'll go a little bit over Jupyter, and you know, it's like pip installed, you know, Jupyter Notebook. You'll have to look it up, sorry. I've got a batch file that I use to run Jupyter, and it's very simple. It's like, hey, Jupyter Notebook. I click on this runs this little server right here, and then all of a sudden the web page just opens up, and you will see if you run it in the directory, which is what you're supposed to do, it'll show you all the files, and then it'll show you the Jupyter Notebooks. So the last one that we saw was the inference. So let's open up the training, because this is what we're going to be using to do our own object detection, basically. And I think, let's see what's going on here. I'll have to read prior files. This is a pickle, okay, SSD, and it's using SSD 300 VGG16. This is also a model architecture. Okay, generator. And I didn't write this code. I've run this code and it works. So this is a pretty good project to keep around. If you want to do your own object detection, and when you get object detection, you get bounding boxes around the objects. You really need that because you need to know what is the where is the object within your space. Okay, so it looks like he's doing the weights. I haven't, gotten too much into this code. Um, I'm not, a super duper expert on, TensorFlow and Keras. I just go out and I find, I learn what VGG16 means. I learn what SSD means, the 300, and I learn, okay, this is the class of model that I want, and it's written in the type of code that I want to use. I've got 100 other projects that do different things other than object detection, and they all run off of TensorFlow and Keras, and that's what I learned on. So I won't be going, to any of the other, technologies anytime soon. So I'm just kind of scrolling through here. What's he doing? Enumerate. I don't know if this is training or not. Maybe this isn't. Maybe he's not. No, he's doing it right there. So this is the call that you make to fit. Okay, fit the model, and then what he's doing is, yeah. So he's using what they call transfer learning, which is you take an existing model that's already been trained, you load those weights, but then what you do is you freeze the model's internals, and then and that's this code right here. So he's using transfer learning, which is great. That means we're not training from scratch. What we're doing is we're retraining a model that's been through thousands of hours. But in order to do that, you have to freeze the layers that have all the good stuff in it. Then what you do is you take the top of the model, what they call the head, and you replace that with an untrained version, and then you retrain that part. So you're using the very last part of the model. That's what you're retraining, and that's why it runs so fast. He's using Python generators, and what these are doing is these are running over the image files, and it'll just constantly run. And he might be doing some, there's the batches, he is doing some callbacks, so you can get your history data out of the model as it's running. And these are things you'll just have to learn over time, but that's why this is a great example, is that when I first got involved with this, I went out to Dr. Adrian's site and got PyImage search. He was using Cap-A. I'm like, what's Cap-A? I don't know what that means. But he didn't go into any of this detail. Let's see. Yeah. Here's the callback. Yeah. And this basically, yeah, does a model checkpoint every so many epochs. Epochs is just you're running over the data over and over and over again. Yeah, path to your JPEGs. So, yeah, and then you create a generator that's going into this directory. I have not run this code yet. I apologize, but I pretty much know how it works. I do know that this code works. So the next thing will be is training. Now, when you use transfer learning, What's he doing? I think he's training it just to recognize plastic bottles. Oh, that's pretty slick. So you see right here, this is a conveyor belt, and trash is going down the conveyor belt, and he has trained uh, this model architecture using the BGG16 pre-trained model to pick out bottles, plastic bottles. That's pretty slick. So anyway, this is a lot to consume. I will go back to, well, let's see, let's try to run it. So to run these things, you click on the cell and you hit Shift Enter. And then you'll see right now this star that's running, and that means it's trying to load. You come over to the server's doing a bunch of stuff. I've got a GTX 1080 Ti with 11 gigs of RAM. That's, you don't necessarily need that, but most of the projects I run into need more than 6 to 8 gigs of RAM. You don't have to do it on your local machine. You can run all this stuff in Google's Colab, but then you have to understand how Colab works. So you get the one here and it says it's done. It's complaining a little bit. This is no big deal. We come down here, Shift Enter. We come down here, Shift Enter. Here it created the model. Now it's loading the model with the weights. That's done. Now we're going to load a pick. That's done. Then we're going to do a prediction. And sometimes the first time it's slow, and then the next time it's fast. See, almost instantaneous. And I'm just holding down Shift on it. I hit Enter. I don't like when it does that. 11 milliseconds is how fast it takes. And then this code right here is going to make all the boxes and the labels. Oh man, didn't work. Interesting. Oh, that's a bummer. I think I've seen this before, and it could have been because I did the predict again. Images. I'll have to go back over this. I apologize. I just ran this thing not too long ago. I didn't have any problems with it. But you can always rerun stuff. So you notice it did that almost instantaneously. That's interesting. Sorry about that. It's the wonderful world of, yeah. So that's the goofball stuff you run into. You run it once, or you got to run it in order. But here's the boxes. It got 100%. So this model is a really good model, and it's relatively fast. With Jupyter Notebooks, you can click on a cell and you can change the cell's type. You could say it's code or it's a markdown. If you double click it, this is the markdown. It's pound pound whatever pound pound, and then you just do Shift Enter. This is just regular code, and I use these Jupyter Notebooks for all kinds of stuff. You can plot the training in real time, which is pretty slick, and you'll have a little plot showing up. I would strongly suggest, if you're getting involved with any kind of machine learning, you get up to speed with Jupyter, because you can prototype things really quickly. So there's a bunch of other things with Jupyter Notebooks as well. You can have widgets in here. You can communicate to external processes. I've done that before. So but I'm not going to go into a lot of detail. Um, I know this is all over the place, excuse me, and I just wanted to put this video out to prepare people if you want to follow me and you want to recreate this stuff when I start putting the source out. There is actually, it's not that much source of mine, to be honest with you, but you're going to have to be prepared with obviously having Unreal set up, and I think this is 4.23 because that's the last version of Unreal Python. If you want to download those binaries and use them, I've got 4.25 working now with a modified version of Unreal Python plugin, and I will provide those binaries so that way everybody can be running on at least 4.25. And as you've seen in my other videos, there's some animation things I'm doing which uses the exact, almost exact code. But this code right here has been talked about in my other machine learning video, so I won't be going over that. I'm still trying to formulate, well, now we've got the object detection inside of Unreal. Well, now what are we going to do? So I'm also looking at the reinforcement learning models to maybe work in conjunction with the convolutional image models to where we can have something that's relatively fun to do. But I think right now the video's long enough, and if you've gotten this far, that's great. So this is again a hyper ramble. You've got the previous version video to take a look at. Now you've got the roadmap for the getting up to speed with a Jupyter Notebook, so we can not only use a MobileNet model that knows how to do this object detection, but now we can retrain it and we can get all of its goodness, but we can get it to detect the the images, the objects that we are interested in, and that's way beyond what the PyImageSearch stuff was making available. Not to knock PyImageSearch, I've learned a lot from them, but I'm starting to move on. Anyway, hope you enjoyed it, and just kind of go over the video a couple times and soak it in. Put some comments in if you don't understand some things, and then that'll kind of guide me with the videos. But I've got two projects that I enjoy working on in parallel. I only get so much time and have so much energy to work on them. I'm a professional software engineer during the day, and I have to write software systems for other people so I can make money. But I'm hoping someday to where I can just do this full time and have much more better quality on the videos. So that's all I got right now. Thanks for tuning back in. Sorry it's been such a long time. I will try to speed things up as we run into 2021. Thanks a lot.